Hey, welcome back. All right, do we have a volunteer who wants to read all this mumbo jumbo up here? Awesome, thank you, miss. All right, guys, let's go ahead and get started. Go for it.
All right, let's start with limits. What is a limit? What is the final limit? Let's start with the notation and go from there. The notation for a limit will look like
Limit, yeah.
lim and f of x equals L. Relax, it's not that bad. This is red. The limit of f as x approaches c is equal to L. If you want to call the function f of x, then you could also say the limit of f of x as approaches c equals to L. Basically, informally, a limit is a y value which approaches as x approaches some value. Limit of
Yeah.
f of x approaches c.
All right, let's slow down.
Yeah.
So here's how we read it, guys. Limit as x approaches c of f of x equals L. And go for it. Oh, shut up.
Means as wait, where did
I'll read it, don't worry. Limit as x approaches c of f of x equals L means as x approaches c, f of x approaches a y value of L. You will see limit as x approaches c, and in the little upper right hand corner there's a minus sign. That means from the left. So f of x equals L. Limit as x approaches c, that little plus sign, that equals L. That means from the right, the little plus sign. And I tell you that in the next phrase. This means x is approaching from the left or right, respectively. Let's practice finding limits graphically and using correct notation. So from algebra, and don't worry, we're going to talk about this. The graph to the right is f of x equals 2x squared plus 5x minus 3 over x squared minus 9. The coordinates of the hole on this graph are negative 3, 7, 6. So we're going to chat really quick. Do you remember how to find vertical asymptotes and horizontal asymptotes? So hopefully you're like, okay, I'll stop. Let me slow down. If you spit in the ocean, does the ocean rise? No, the ocean doesn't rise if you spit in the ocean. Doesn't matter how many of you take to spit in the ocean. I know it's gross. That's Chavez, that's gross. Yeah, you're right. So the analogy of that is, what is spit, what is ocean? So in the numerator, the one with the highest degree is ocean and everything else is spit. In the denominator, it's the same deal. That's for end behavior, right? So look at the numerator, the 2x squared plus 5x minus 3. So what is ocean? The 2x squared. As x approaches infinity, the 2x squared takes precedence. In the denominator, what is ocean? The x squared. And if you don't get my analogy, then don't worry about it. You can just use your horizontal asymptote rules. Notice that you have 2x squared over x squared. The x squares cancel out, and it's just 2. That's your end behavior. Do you guys remember that? So all that means is, as x approaches infinity, you're going to be approaching the number 2. As x approaches negative infinity, you're going to be approaching the number 2. Because all that means is 2 times some huge number divided by that same huge number. The x squares cancel out. Right? 2 times a big number divided by that same big number. So that's all it means, guys. You can be a robot, but I don't want you to be a robot. Make sure you understand why the end behavior is 2. And don't worry, we will talk about this in more detail soon. You know what? Let's talk about it right now. So you don't have to do anything, just observe. If I take out my calculator here, so look, check it out, guys. You don't need a calculator. I'm just going to take mine out really fast, just because I want you guys to understand this behavior issue. So come on, buddy, hurry up. It's supposed to be fast because it's tied to my computer here, but it hasn't even opened the app yet. All right, here we go. Okay, y equals clear, clear, clear. All right, what did I have in the numerator? 2x squared plus 5x minus 3. And then divided by, and then parenthesis, what was my denominator?
x squared minus 9.
Okay, here's what I mean. If I go to, I'm going to set up my table. I'm going to put ask. If I make my x really, really large, what is my y approaching? This is what I mean by end behavior. So if I put 1, it's going to give me 0.5. If I put 10, it's going to give me 2.7. If I put 100, let's see what that is. It's going to give me 2.05. If I put 1,000, it's going to give me 2.005. If I put 10,000, I think I put 100,000. Let me get rid of another 0. Oh, it's 100,000 there. Too bad. 2.00001. Look what's happening. And it says 2, but it really isn't 2, guys. If I scroll, look, 2.0000005. As x gets larger, the y value is approaching 2. That's where this whole rules for horizontal asymptote comes. Like the rules, remember, if the denominator is bigger than the numerator, it approaches 0. Do you guys remember that from Algebra 2? Like, you can be a robot and understand those, but make sure you understand why. It's because of the end behavior. The higher the degree of a polynomial, that's the one that takes precedence as x gets larger. So it's a whole spit in the ocean idea. What's ocean in the numerator? What's spit? What's ocean? You know, what in the polynomial, what is ocean? Whatever has the highest degree. So highest degree divided by highest degree, exponents cancel. That's how we find our y horizontal asymptote, or whatever that is. Does that make sense, guys? So this is how we found this y equals 2, which is this guy right here, see? All right, now what about this vertical asymptote at positive 3? Well, like this. Well, check it out. I'm going to write, well, I guess I'll write it like this. 2x squared plus 5x minus 3 over x squared minus 9. This 2x squared plus 5x minus 3 factors out. Hopefully we remember, and it's okay if we don't. Yeah. Yeah, I think, let's see, 2x minus 1, right? And then x plus 3. And then let's see if it works. 2x times x, that's 2x squared. 2x times 3, that's 6x minus 1x, that's 5x. And then negative 1 times positive 3, negative 3. Perfect. And then the bottom is the difference of squares, which is perfect. And then check out what cancels. I have a factor. I have an x plus 3 in the numerator and an x plus 3 in the denominator. If I have common factors, the top is a product and the bottom is a product. You're multiplying. But then you have this quotient dividing. Product and quotient cancel each other. They're inverse operations. So this x plus 3 cancels out. Yes or no? So this function behaves, by the way, it does not equal, but it behaves. This function behaves like 2x minus 1 over x minus 3. Now, remember your domain. Okay, I'll slow down. Wherever the denominator is 0, this function does not exist. Does that make sense to you guys? Because you can't divide by 0. So this x squared minus 9, x cannot equal positive 3 and negative 3. Negative 3 squared is 9. 9 minus 9 is 0. And 3 squared is 9. 9 minus 9 is 0. Does that make sense? Hopefully you remember. If you don't, that's okay. Notice that we cancel the x plus 3 factor. That means we have a whole at x equals negative 3. The factor that you cancel out, you have a whole there. And then the factor that you could not cancel out, you see this x minus 3 there in the bottom? That means x equals 3 is a vertical asymptote. Is all this making sense to you guys? Okay. So notice x equals 3. There's my vertical asymptote. Notice at negative 3, I have a hole there. Chavez, how did they find that y value of 7, 6? I'll show you how they found it. You see how this behaves like this? Insert a negative 3 into there. 2 times negative 3 minus 1 over negative 3 minus 3. 2 times negative 3 is negative 6, minus 1 is negative 7. Negative 7 divided by negative 6. Negative divided by negative is a. So I have a hole at, let's see, where was I? At negative 3 comma 7, 6. So that's how they found that expression, or that hole. Are we okay so far? Okay. Now we're good, I think. Now here we go. We're going to go with the fun stuff. I'm going to go slow. Stop me. This is the first time that we've been doing limits. I don't think we covered limits last year. So turn the page. It's the same graph. Remember that hole is negative 3 comma 7, 6. And we don't care about continuity. We just care about, remember what it says here. What it says here in the notes. It's the y value you're approaching. Right? This means that x approaches c, f of x approaches the y value L. So you will also see blah from the left, from the right. This means left, and this means from right. This means that x approaches from left or right, respectively. Let's practice finding limits graphically and using correct notation. All right, here we go. So let's look at this graph. I'm going to go slow. As x approaches negative infinity, so remember, you're in this curve. You can only travel on this curve. As x approaches negative infinity, so as x gets larger in the negative direction, what is my y value approaching? 2. So this looks like that. As x approaches negative infinity, the graph of f of x is approaching 2. Guys, it is a safe space. I heard you whisper 2. Say it loud and proud. And if you're wrong, it's okay. It's okay. That's how we got, trust me guys, look how many mistakes I make. It's okay. Make a mistake. It's all good. Make a mistake on purpose. All right. How does it look with calculus notation like this? Limit as x approaches negative infinity of this function, f of x. You can also write the expression of the function, which is all this stuff right here, 2x squared plus 5x minus 3 over x squared minus 9. But it's just easier to write f of x. Limit as x approaches negative infinity of f of x is equal to, and what did it equal? 2. There it is. Cool or not cool? All right, let's look at the next one. Limit, it says, as x approaches positive infinity, the graph of f of x equals, so you're writing the curve. As x approaches positive infinity, what does the y value approach? 2 again. See? So how are we going to write it? Calculus limit notation. Limit, and then on the bottom right, x, put an arrow sign. That means approaches, and then put infinity, put f of x, and put the number 2. How do we feel? Easy, right? Nothing crazy? All right. As x approaches negative 3 from the left, the graph of x approaches, okay, so let's go to the graph. So I'm approaching negative 3, and you have to approach the curve, right? So you got to write the curve here. So if I approach negative 3 from the left, so there's from the left, what y value am I approaching? What's this y value here? Yeah, 7, 6. Say it loud and proud. 7, 6. If I approach negative 3 from the left, I'm approaching that 7, 6. Because that's where I have my hole. Does that make sense? All right, so how does it look in limit notation? Notice that we're approaching from the left. So here's how you write it. I'm going to go slow. Limit, so LIM, as x, put an arrowhead, and then put negative 3, and then on the upper right-hand corner, put a little minus sign. That means from the left of f of x equals 7, 6. How do we feel so far, guys? All right, here we go. As x approaches negative 3 from the right, the graph of f of x approaches. So let's see, negative 3 from the right. So here it is, negative 3 from the right. What am I approaching? The same hole, 7, 6. So then we're going to write limit as x approaches negative 3 from the right of f of x, and it's the same deal. How do we feel? All right. Notice that the next one just says limit. It just says as x approaches negative 3, the graph of f of x. So if it doesn't tell you from the left or from the right, that means check. Like, if you approach from the left and the right, do I approach the same output? Yes. So as x approaches negative 3, I just approach 7, 6. And I'm going to write limit as x approaches negative 3, and you don't put a plus or a minus, and you write f of x equals 7, 6. I know you guys have been up since 5 in the morning because of senior sunrise. So having 9th period calculus is tough. It's tough, but we can do it. How do we feel, guys? Okay. Before I continue, I want to see, let me see if we can test your brains a little bit. What would have happened? What if? Don't write this down, just listen. What if this one would have been a 1 or a 2, it doesn't matter. What if this would have just been a different number, like a 2, and this would have been 7, 6? Then what would I have said on this one? If I approach from the left, it's 7, 6. If I approach from the right, it's a different number, it's 2. So if I have different values, what do you think this one would have been? Starts with the letter D. It's a Lindsay Lohan. They used to call her Lindsay Lohan. She came out in a movie and she said this famous line. Yeah, do you remember when, I think of the movie with Mean Girls, the limit does not exist. Do you guys remember that? Yes. Okay, so when does the limit not exist? If you are approaching two different values. If you approach from the left, if you approach from the right, if they approach two different values, the limit does not exist. Don't worry, we'll figure this out and we'll put some more notes in here. Cool or not cool? All right. So now this one just says limit as x approaches 3 from the left, or it just says as x approaches 3 from the left, the graph of f of x equals. Okay, so if I approach 3 from the left, it looks like it's approaching negative infinity. You can also say it does not exist because you don't converge to a number. So you can say both are solid. You can say negative infinity or DNE. DNE stands for does not exist. So you can write limit as x approaches 3 from the left of this function, and you can say either negative infinity, which is a behavior, or you can say DNE does not exist. How do we feel, guys? Nothing crazy? All right, let's go to the next one. We're still looking at the same graph. It says, as x approaches 3 from the right, the graph of f of x, so let's look at this graph. So I'm on the curve, and I'm looking for the y values. As x approaches 3 from the right, my y values are positive infinity or DNE. If it's a multiple choice exam, you will never see both answers. It'll be one or the other. How do you write it? Limit as x approaches 3 from the right-hand side. You put a plus symbol in the upper right-hand corner of f of x equals positive infinity or DNE. How do we feel? Okay. As x approaches 3, the graph of f of x, okay, because it just says 3, one approaches positive infinity, one approaches negative infinity. So you can't give a behavior, but you can give an answer. My answer is going to be does not exist. You're not giving a behavior because it's two different behaviors. Does that make sense? So now we're just going to write limit as x approaches 3 of this function equals does not exist. How do we feel? Anything crazy so far today, guys? Yeah, nothing crazy. And this is just saying what we said earlier, the definition, one-sided and two-sided limits. Sometimes you can only approach from one direction, like at an endpoint. But it says here, a function f of x has a limit as x approaches c if and only if the right-hand and left-hand limits at c exist and are equal. So that's just saying if my limit from the left equals the limit from the right, then you can just say limit of that as x approaches that number is just whatever that limit value is. Does that make sense? That's just what we did right here, in case you're wondering. Limit from the left approaching limit from the right, I approach the same y value. So you can just say limit as x approaches negative 3, 7, 6. Cool or not cool? Yeah, don't worry, we're going to practice. We're going to practice a whole bunch. Some of you guys are looking at me like, Okay, so look, check it out. I have a graph. All we're doing right now is just graph. We're not doing any algebra. So we have a graph. There's only one way to approach negative 1. You can only approach from what side? From the right. That's the only way. So look at number 1. As x approaches negative 1 from the right-hand side, what is my limit? Is it 2? Is it 1? I'm approaching negative 1. 1. Do you guys see how we did that? Okay. Look at letter B. Letter B is approaching 1 from the left-hand side. So here we go. So let's see. I'm going to pick on someone, and it's okay if you're wrong. Who wants? Okay. Sorry, I don't know who to hit up. Flores. I was going to hit you up first, but then I changed my mind. Okay, you know what? We'll hit you up. All right. If I approach 1 from the left-hand side, I'm approaching 1. If I approach 1 from the left-hand side, what is that limit? Yeah, it's a circle. What's that y value?
1.
That's not 1. From the left. It is...
Oh, I was looking at the wrong one. Sorry,
2. Does everyone see how the limit of x approaches 1 is 2? It's okay, miss. This is a safe space. What's up, Gian? Hit me.
Why are the dots like different? Does it matter if you like?
Yeah, it just means that from the left, this is not part of my domain. My domain is the number 1. That's a good question. In a little bit, I'm going to ask. Ooh, you know what? Let me FG. What's A, B, C, D, E, F, G, H? I'm going to ask that question right now. F of 1. Yeah. Don't worry. We're going to have some more questions. All right, Gian, you got the next one. No, it's a safe space, miss. Limit as x approaches 1 from, what does that plus symbol mean? From the right. So I'm approaching x equals 1 from the right-hand side. What is that y value? 1. Good job. See? Good job, guys. All right. Limit as x approaches 1. It doesn't have a plus or a minus, so that means my left-hand side has to match my right-hand side for it to have a limit. Does my left-hand side equal the right-hand side? No. So what am I going to say? DNE does, I'm going to spell it out this time, does not exist. Because I'm going to spell it out because I have the room. Not that I didn't have the room last time. I probably could have spelled it out. But sorry, guys. All right, I just wanted to write the whole thing because I felt like it. Cool or not cool? Hey, you are you happy, miss? All right, yay, good. I want you to be happy. Limit as x approaches 2. What do you guys think it is? 1? Yeah, it is. It's 1. Good job. If I approach 2 from the left-hand side, we're looking at the y value. What is it approaching? The y value is 1. It's always 1. If I approach 2 from the right-hand side, go from the right of 2, it's still 1. Do you guys see that? Oh, okay. Good question. That's, okay. We'll get to it in a little bit. Just a little bit. All right. There's only one direction to approach for 3. It says limit as x approaches 3 and a little minus sign on the upper right-hand corner. That's because there's only one direction to approach. If I approach 3 from the left-hand side, what is that y value? 1. Okay. Look at letter G. Does the letter G have the word limit in the front? It does not. So that just means f of 2. When x is 2, what is my y value? This is a function. When x is 2, I have a hole at 1. So you're not defined there. Where is it defined at x equals 2? At 2. So f of 2 is 2. Does that make sense? Look at letter h that I just made up. Letter h does not have the word limit in the front. So all that means, when x is 1, where is this function defined? When x is 1, this function is defined at 1. So this is different from a limit. This is like, where is it just defined? Where do I have a point? Or where is the curve defined? Cool or not cool? Cool. All right, let's continue. We're doing good, guys. We're doing good. Can we take some more? Okay. How many of you have been up since 4 in the morning? Okay. How many have been up since 5 in the morning? How many since 6 in the morning? Okay. So you guys probably got like 3 hours of sleep or something. The first day of school is always hard for me. I have anxiety and I don't sleep well either. Yeah. Yeah, it's crazy. It's crazy. All right, here we go, guys. Here we go. You guys ready? This one here, it says limit as x approaches 3 from the left-hand side. So I'm looking at 3, and here I am. So I'm focusing on 3. If I approach 3 from the left-hand side, what does that y value look like to you? 1. Perfect. Put a 1 there. Then it says limit as x approaches 3, and I have a little plus symbol. What does that plus symbol mean? From the right. So look at 3, and I approach from the right. What does that y value look like to you? 3. So I'm going to put 3. And then it says limit as x approaches 3. So that means I got to check my y value from the left and the right. Are they the same y value? They're not. So what am I going to write? D and E does not exist. Does not exist. And then it says f of 3. Ooh, am I even defined anywhere? Okay, you're not defined anywhere. I don't see a point anywhere. So you say non-existent. Did I spell it right? Because it's not part of the domain. Non-existent. Which is kind of a little different than does not exist. Sorry. Yeah. Yeah, like does not, like non-existent is not even part of the domain. There's no, oh, they don't count on spelling. Did I spell it wrong? Non-existent. Yeah. No, I think I spelled it right. All right, example 3. So here we go. It says use the graph of the function f of x shown below in order to determine all values of a for which x approaches a of f of x equals 0. So they want me to figure out what the a is between -9 and 9. You guys ready? Don't worry, we're going to go slow. So where on this function is my limit 0? Well, I see that my limit is 0. I'm reading the graph left to right. Where's the first time that my limit is 0? At what number? No, be careful. The function is defined at -7. It is 0, the function, but not the limit. So the limit has to be, the curve has to approach 0. Does that make sense? So at negative, not -7, but -5. So that's my first value. A equals -5. Let's see, where else do I have? I have another one. A equals where else? At 2. Good job. Oh, yes. 7 is 1, but only from what direction? Which one? From the left. So I'm going to, yeah, only from the left. So if I were So notice on this one, it doesn't have a plus or a minus symbol. So 7 is not going to be included. There is one more. What's the other one? 8. A equals A. Why are it those three only? Because you can write this. Limit as x approaches -5 of this function equals 0. Limit as x approaches 2 of this function equals 0. And limit as x approaches 8 of this function equals 0. Yes, yes, some of you said 7. If you would have said this, 7 from the left, that equals 0. But is there a little minus sign on that A there? No, so that's why we're not including this one. This is true, but it's not true from the right-hand side. Does that make sense? Okay. I think we're doing awesome, guys. You guys are doing fabulous. Way to go. All right. I think we're good. So these are my answers. These are our answers. All right. Let's go to the next one. Is this the last page? Yes, it is the last page. Yay. Okay. Notice that hey, relax. This is what is called a piecewise function from Algebra 2. They're not hard. Guys, I promise they're not hard. Go slow. You can actually do them all by just looking at this, but I know you guys are visual. I know that because I had you guys last year. You guys are visual. So here's what I recommend when you get to a question like this. Sketch a graph. And they're easy sketches. They're not hard sketches. Notice they're all linear lines. So here's how we're going to sketch a graph. Ready? I'm going to exaggerate. Let me see. I'm going to exaggerate quadrant 1 and 4. And I'm going to put it in blue. When x is 0, so look, it wants me to sketch negative x plus 1. When x is 0, the y value is 1. So I'm going to put a point at 0, 1. Does everyone know how I got that 0, 1? Okay, I'll say it again. You see how it says between 0 and 1, it behaves like that function negative x plus 1? I know that my slope is negative 1, or you can just plug in a 0 into the x. 0 plus 1 is 1, right? When x is 1, I know it doesn't have the equal sign, so bear with me. When x is 1, negative 1 plus 1 is 0, so I'm going to go to 1, and I'm going to put a hole because it does not have the equal sign. And it's a linear line, so here it is, connected. And that's a hole right there. Does everyone see how I got that hole? Or it's also called removable discontinuity. Are we okay with how I got this? No? Okay. You see how this says between x is between 0 and 1? So between 0 and 1, I bet you if I were to tell you this, you can graph this graph. Negative x plus 1. You see that? That you can graph really quick. You just, negative x plus 1, y-intercept of 1. My slope is negative 1 all the time. It looks like that. But this is only telling you that only graph it between 0 and 1, but not equal to 1. So 0 and 1 is this that I'm going to put in black. At x equals 0 is this. At x equals 1, notice there's not an equal sign. I put a hole. So it's just this in black, which is what I drew here in blue. Does that make sense? Do you get it now? Are you sure? You can say no, miss. I can explain it so many different ways. Yeah. Let me see. Let me explain it a different way. So this f of x equals all this mumbo jumbo. So all it's saying is that I have a y value, or my function is negative x plus 1, but my domain is restricted between 0 and 1. 0, comma 1. So what that means is this. This graph, negative x plus 1, so let me go ahead and graph it with my calculator here. So here's my graph, and I'm going to put negative, I'm going to first type it in like this, negative x plus 1. So if I were to graph this, let me do a regular window. There it is. This is negative x plus 1, right? But I don't want to graph it from negative infinity to positive infinity or all row numbers. I want to graph it. I wonder if I can do it. I think I can. Let's see. I want to graph it only between 0 and 1 because that's where it tells me, right? So let me see. I push this. I push x. And I push math. Maybe it's a second test. And I put... trying to remember how I used to do it. For x, okay, so let me, okay, I got it. For x less than 1, I guess I don't need that. Hold on, x less than 1 and second logic and x greater than 0. And I want to make sure to graph what you want. X greater than or equal to 0. Okay, let's see if it's going to do it. I don't know. I've never done it. Dang it, it didn't do it. I was so confident too. What if I put parentheses? Second, insert parenthesis. Hopefully it'll do it again. Hopefully it'll do it. Let's see. Yes, it worked. All right, look, zoom in. This is what I want, Ms. Guillen. I just want my x between my x value of 0 and 1. It should have an open circle here, but at 0, I mean, it's concluded. You know what I mean? So this is what I mean by piecewise function. I'm just graphing negative x plus 1 between 0 and 1. Are we good? Okay, yeah, ask questions, guys. It is a safe space. If you have to ask 5 different times, I'm human like everyone else. Maybe I'll get tired. Maybe you'll see me getting a little annoyed. But at the other night when I go to sleep, I always reflect back. And if I feel that I didn't do my best job, I'm going to be sad. So I want you to ask. Ask. Thank you. Okay, now look at this. You're going to be able to graph this one. This one, you see this, how it says 1 there? And I'm going to try to color code it. I'm graphing 1 between 1 and 2. So between x equals 1 and x equals 2, the y value is always 1. So here we go. I'm going to say that this was 1 because it was. And I'm going to put 2. And so here it is. Solid circle, open circle. Because it doesn't have an equal sign at the 2. Does that make sense so far? Okay. Now let's go to the between 2 and 3. I'm going to go slow and relax. It's the same idea. All right, so here we go. Before I go to that one, notice at x equals 2, it says equals 2. So x equals 2, I'm going to say 2 is up here. Point at 2, 2. Put a point at 2, 2. All right, here we go. Now we're going to do the burnt orange one. Between 2 and 3, I'm just going to be lazy. I'm going to put a 2 in there because when x is 2, 2 minus 1 is 1. So I know that it starts at 1. So at 2, it starts at 1, and there's open circle again. So there it is, my open circle. And at 3, 3 minus 1 is 2. So at 3, it is at y value 2, and it's a solid circle, and you connect it. Does everyone see how I got it? I just plugged in the number 2 to see where my y value was. I saw that it did not equal, so open circle. At 3, I plugged in my x value of 3. 3 minus 1 is 2. That's my y value. And I put a closed circle at 3, 2, and then I connected the lines because I know it's linear. We okay? Okay, now let's go, and I'm going to choose this color here. Between, where am I at? I already did this one, right? So now I'm going to do the negative x plus 5. I plug in a 3 to see where that hole is at. Negative 3 plus 5 is 2. So at 3, open, well, it's already closed from the other one, so it's okay. I guess technically if you want to do that, but it's closed from the other one. And then at 4, negative 4 plus 5 is 1. So here is 4, and there's 1. Closed circle. Bam. And there it is. There's my piecewise function. How do we feel, guys? Do we feel okay? Okay. All right. Here we go. Now we're going to look at that picture, and we're going to answer these questions here. Hey, relax. It's okay, guys. Letter B. I'm going left to right. What does that little plus symbol there mean? All right. So, Guerrero, can you read me the whole limit expression, and then, we'll see what's up? It's okay, miss. It's fine. We're safe. Perfect. You said it beautiful, miss. Limit as x approaches 0 from the right of f of x. What is it? If I approach 0 from the right, what is that limit? 1. Yeah, good job. It's 1. That's it. See? You're good. Miss Alvarez, you want to help me out with this next one?
Limit as x approaches 1 from the left.
What do you think that equals? If I approach 1 from the left of f of x. Yeah, 0. Good job. All right, Alvarez, you get to choose the next person. Who's the next person? Alex. Next one. Limit as x approaches 1. Oh, read it to me. Yeah, limit as x approaches 1 from the right. Don't say to the right. But it's okay, it's okay. Of f of x equals, so if I approach 1 from the right, what do you think that equals? Yep, good job. 1. All right, you get to choose the next person. All right, Delgado. Give me the next one here. Limit as x approaches 1 of f of x. All right, so what is that limit? Yeah, DNE does not exist. If you approach from the left, it's 0. If you approach from the right, it's 1. They don't match. So it has to be does not exist. Math life. Cool or not cool? All right, let's go to the next one. All right, Delgado, you choose the next victim. I mean, it's not a victim, but. All right, De Leon, give me the next one. Of f of x, what is it? Yep, it's 1. Hey, give me the next one, De Leon. All right, Rodriguez. No, not it's a limit, not the function evaluated at. So here you go. You see how this burnt orange here? So if you approach from the right, that y value is 1. Good job. All right. You choose the next person, Miss Rodriguez. All right, Natalie Espinosa. Equals. Yep. Why is it 1? Yeah. Good job. The approach of 2 from the left is 1, 2 from the right is 1, so it's 1. All right. Choose the next one, Espinosa. Daniela. Yep. Yeah, limit as x approaches 3 from the left. So be careful with saying limit of x. So limit as x approaches 3 from the left. All right. Contreras, who do we ask next? All right, Ms. Guillen, hit us with the next one. Mm-hmm. Yep, good job, miss. All right, Guillen, who are we going to ask next? All right. Lavelle? It is, but you got to read me the statement.
Oh, yes.
No, you're good, miss. Limit as x.
Limit as x approaches 3 f of x.
Perfect. Limit as x approaches 3 of f of x is 2. Good job, miss. Okay, who are we going to ask next, Miss Lavelle? Pretty much asked everyone almost, except for these. Oh, we already asked her. Miss Flores, you want to go next? Because we only have 2 people.
The limit as x approaches 4 from the left, f of x.
Perfect. And Jamili, you want to do the last one? It doesn't say the word limit. It just says what? F of 2, right? So all that means is f of 2 equals, what do you think? 2. Good job. That's not a limit. That's where the function's evaluated at. When x is 2, what's the y value? Good job. You guys did good. How did we feel? All right. So in your table, don't worry. We're doing good timing. We're doing okay timing. Not the best, but not the worst. But you guys are working really hard, and I appreciate that. All right. So take like 3 minutes. See if you guys can figure this one out. It's not hard, guys. Think about it for a little bit, and then we'll work on it together in a little bit. So take about 2-3 minutes. You guys can talk. Talk, guys. Are you feeling okay? Allergies? I don't think you guys need a calculator. I don't think you do. Yeah, draw it.
I like it. I know one. I know one is you. How far do I need to go? Oh my gosh.
For avalanche.
So it's like a. Oh,
You guys got an answer?
is the sorry, I like on the track at 1.
0, 1, yeah.
Oh wait. Sorry.
All right, guys, I'm going to go ahead and get started. You guys are making it really hard. It's not that bad. It really isn't. Okay, let's go back to our Algebra 2 days. So it says, let f be defined, and it's a piecewise function. Notice it's x squared plus 1. It's a quadratic. It's not linear like the last one. Chavez, I can't do this one. Yes, you can. When x equals 2, it's 1, and it's 5 between 2 and 8. Okay, let's relax. Does everyone know how y equals x squared looks like? Yeah, y equals x squared just looks like this. Well, it goes through the origin, but yeah, like that. Right? So x squared plus 1 looks like this graph, but just moved up 1 time. So I'm going to say negative 2 is like right here. I'm going to say 2 is like right there. And I'm going to go solid circle, and I'm going to go like this. And open circle. How do I know what those y values are? Well, yeah, let me draw it a little better. Okay, how do I know what those y values are? Negative 2 squared is 4 plus 1 is 5. So this must be 5. 2 squared is 4 plus 1 is 5. This is a whole. It's not an equal sign, so make sure that you have a whole at 2 comma 5. Does everyone see how I got that expression between negative 2 and 2? Okay, when x equals 2, what is the output? When x equals 2, the output better be 1. So this is 2, 1 right there. Because of this. This is a point right here. If it's just x equals, that's just a point. X equals 2, so 2, 1. And then I am 5 between 2 and 8, so that's just a horizontal line. So here, this was already 5 here. I'm going to say 8's like right there. So here it is. And hole right there. And there it is. That's my sketch. Maybe the x scale is not perfect, but that's okay. Cool or not cool? All right, here we go. What is the limit of f of x as x approaches 2? So here's what I'm going to write. Limit as x approaches 2 of f of x. You can also say limit of f of x as x approaches 2, which I think is how I wrote it in the notes, but maybe I said it, or I said it the other way around. It doesn't matter. Limit of f of x as x approaches 2, or limit as x approaches 2 of f of x. Okay. If I approach 2 from the left-hand side, the value is 5. If I approach 2 from the right-hand side, the value is it 5 on both occasions? So then the limit of x approaches 2 of f of x is simply 5. How do we feel? Yeah, good job, guys. So I have a handout. I think you still got enough time to do a little more. Don't worry. Hey, relax. This is your first activity that you can do together as a group. But we're going to get you started. I already passed it out. Yeah, we're going to do more advanced levels. Not tomorrow, but tomorrow we're going to practice some more on this. But we're going to do more advanced ones on Wednesday.
Did you just give us homework?
No, this is actually an activity for today. But yeah, we might not finish it today, so maybe. Oh, I didn't give you one. Sorry again. All right, guys. So we're just gonna get you guys started. This is an activity. It's a very first 100, but relax. You're gonna do it as a group. We'll get you guys started. So look at number 1. It says for the function f of x shown below, determine limit as x approaches 3. What does the little minus sign mean? From the left. So if you look carefully, if you approach 3 from the left, what does that y value look like to you? -6. So I would write it like this. Down here, write limit as x approaches -3 of this function equals -6. You guys see how we did it? Let's go to number 2. Where's number 2? And then we'll let you guys loose with your crew. For the function f of x shown below, determine. Notice, did it say the word limit? No. So you're just going to go f of -1, and I look to see if I'm defined, and it doesn't look like there's a point anywhere. So you either say non-existent, or you can say undefined, because it's not part of the domain. There's no value anywhere. This is not. It's a quote unquote. It's a little different than does not exist, because not exist is like for limit behavior. If it's a function, it's non-existent or undefined. How do we feel? All right, let's do another one. Let's go to number 3. This one says limit as x approaches 4 from the right-hand side. So I look at 4 from the right-hand side, and what y value does it look like to you? -6 again. Limit as x approaches 4 from the right-hand side of this function is -6. See? Let's go to number 4. -3 from what direction? From the left. See, limit as x approaches -3 from the left of this function equals, what does it equal? -4. See, you guys kind of got it down more or less. And it's okay. These are activities, guys. It's okay for you to talk amongst each other, help each other out. Let me know when you get stuck. And yeah, that's what you're doing. All right, let's do one more. Look through the whole package. Look at one that looks interesting to you and tell me which one you want me to do. Number 10? Okay, everyone go to number 10. All right, number 10. And this will be the last one we do. It says, answer all of the questions below about the function f of x graph below when x equals -6. Write DNE and undefined to reference values that do not exist or are undefined. Okay, whatever. All right, here we go. Ready? Limit as x approaches -6 from the left. So I go to -6. If I approach -6 from the left, it looks like it is 3. Now I'm going left to right, so I'm going to the right one now. Limit as x approaches -6 from the right. Well, it's a continuous function. If I approach -6 from the right, it is also 3. Limit as x approaches -6. Well, they both match, so it is 3. And it's a continuous function. There's no hole there, I don't think. Let me erase. Nope, there's no hole. So f of -6 is 3. This is what's called, we're not there yet, but this is how you find whether something is continuous or not. Technically, you can say this is a continuous function because the limit equals a function. Don't worry, we'll get to that when we get to it. Okay, one more. Which one else? The last one? Okay. 22. No, it's like the one from the notes. Use the graph to the function f of x shown below in order to determine all values of a for which limit as x approaches a is -4. So I show -4. Where's -4? Down here on the intervals. If there are no values of a, write none. Okay. I see 1. That one right there. I know there is 1 if you approach from the left or from the right, but I want from both directions. So if you want, if it makes life easier, you can draw a horizontal line of -4. And there it is. There's 1 right there. It's a hole there. So a equals 7. Limit as x approaches 7.
Students, faculty, and staff at this time, we are going to do
That's what it means.
afternoon announcements, so if we could have everyone's attention. If everyone could please have attention to
Cool or not
the
cool?
following announcements for this afternoon.
Ask Flores.
Good afternoon, students
Okay.
and staff. We want to thank everyone for a wonderful first day back for the school year. We do have birthdays for the month of June. Gabriela Zavala, Adelaide Alonso, Carolina Calderon, Jimena Rodriguez, Lauren Perez, Janelle Mutier, Emma Marie Figueroa de Leon, Sophia Berry, Frida Velasco, Dalia Rubio, Alidia
We're doing Empower.
Padron, Asma Amini, Erin Morales, Katie Bernal, Giselle Reina, Isel Bastillo, Camila Valero, Liliana Hernandez,
Sorry, what?
Eliana Willingham,
What?
Brittany Wright, Brittany Rioja,
That's the only activity we're gonna do together.
Johnny Clark,
Yeah.
Laureli
But
Gonzalez,
it's fresh right now in your head, so see if you can do a little more, if you can, in the next 10, 15 minutes, you know? If you can.
Marina Rivera, Cassandra Hernandez, Madeline Ortiz, Ana
I know, but, you know, like, you can stay here after school if you want. Yeah. Well, I mean, you're already here. Might as well work on it together, you know? Yeah, this is fresh, guys, in your head. So try to do as much as you can, if you can, today. But it's not homework. If you want to do it tomorrow in class, that's fine. But yeah.
Sure that you can get up from the main office. It is your responsibility to do so. The front office is not going to